Hello everyone, welcome to this LeetCode daily where we are going to go through validate binary tree nodes. In this problem we receive as input two arrays representing the left child and the right child of each of the nodes, and we receive as input the number of elements we have in the nodes, right? And we are supposed to validate if that input is actually a valid binary tree. What is a valid binary tree? So a valid binary tree is actually a tree where each of the element has exactly one parent, there is no cycle, and all of the elements are actually forming one tree. So they are actually one component. This is a valid binary tree. This is not a valid binary tree because this element has two parents. This is not a valid binary tree because there is a cycle. This one is pointing to this one is pointing to this. So now, given those elements, how are we going to solve it? How are we going to organize ourselves to solve this problem? Before diving into solving the problem, if you're new here, yes, Algo Architect, here we are solving LeetCode daily occurring solution. So if you're interested in any of those, don't hesitate to subscribe to not miss what you're doing here. And if the video you're looking is actually interesting, is actually bringing you value, don't hesitate to like and share. And if there are things that you think we need to add to the video to make it more interesting, don't hesitate to comment. Okay, so now for us to solve this, how are we going to approach it? So we are going to break the problem into four steps, right? And then the first step is to check the relationship between nodes. So the goal of this is to find if the various node has unique parent. So this is the part we are going to check if node has unique parent. And then after that, we are going to check for cycle. And to check for cycle, we are going to first check for the root node. So we are going to find the root node, and from that root node we are going to kind of build the our I would say our graph, our tree. And while building our tree, if we find cycle, we are going to just return false. And then at the end of the building the tree, we are going to check if the tree we build is actually complete. That means, does it contain all of the elements? If it contains all of the elements, then we return true, otherwise we return no. So basically we are going to play with this. So let me draw this. This is 0 1 2. So if you are to draw this, you are going to have something like this, like this, and like this, right? Let me use another color for the node. So we have 0 here, we have 1 here, we have 2 here, and then we have 3 here. This one is linked to this, this one is linked to this, and this one is linked to this. So basically the process of checking the parent, how are we going to implement this first step, which is check parent-child relationship. So to check the parent relationship, we are going to look through the left child and the right child. So we have an array left child and right child. What we are going to say is that if the left child is actually different from 0, from -1, that means there's an in relationship between the node at that position and the element which is at the left child, because -1 means that there is no element at that position. A value means that there is an element at that position, and the element is the element with that value. That means, for instance, this one, since left children of 0 is pointing to 1, that means there's a relationship between 0 and 1. And how are we going to use it? If left child of 0 is actually 1, that means 1 has for parent 0. So that is what we are going to use here. If the parent of left child of an element is equal to -1, that means that element has no parent yet. Then we are going to say, okay, that element is going to have as parent the pointing element. So let us take this example. We have left child of 0, which is 1, and we are going to say if parent is the array of parent of left child of -1, left child of 0, that means parent of 1 is equal to what? So we are at the initial state. Parent, maybe I missed this. I have an array of parent here, and I initiate everyone to -1. So initially I consider no element as a parent. So now I'm going to check what is the parent of 1. I will see that there is no parent for 1, and I will assign to 1 element 0. That means the parent of 1 is actually 0. And if when I'm checking for a parent of someone that I want to add, it already exists, that means that element is going to end up with 2 parents. For instance, this one is going to be defined as the parent of 3, and we are going to see again that this 2 is also the parent of 3, so this will be invalid. So, and then this is the part of the code that we handle it. Whenever you want to assign a parent of someone and it already has a parent, that means it's a duplicate. So this is the part of the code that is going to handle the relationship in between nodes. So now at the end, I'm going to find the root. So the root is basically identified by the element who has no parent, right? So to find the root, I'm going to loop through my parent array, and while looping through the parent array, I'm going to check if the parent of that element is equal to -1, that means it is a root. So I'm going to say if root is equal to -1, root will take I. Why am I checking here again? Because I can find myself with 2 roots. That means if I've initialized here root at -1, so if I'm seeing an element with no parent, and if the root is -1, that means the first parent that I'm seeing, I'm going to give to the root -1. That means that is the root of our node. But if after that I see again an element with a parent of -1, eventually at that time root will not be -1 again because it has been affected here. So I need to return false because I have multiple root. So this part is actually responsible of finding the root, and in case I have multiple root, he will actually handle it and then return false. Now at the end, it can happen that by checking this, I have no root. Let's say I have an array maybe consisting of just 2 elements, which is 0. This one, for instance, this one has no root because this one is the parent of this one is the parent of this, so there's no root. This case, for instance, it should return false, and this is the part of the code which is handling that. Now at the end of it, what I should do is that I should not detect for cycle. What will my approach of detecting for cycle? So to detect for cycle, I already have a root, so I'm starting from a position which is my root. And what I will do is that I will create a kind of set which is visited element, on which I will add my various elements. I will start by adding the root, which will be 0, and I will say, okay, I'm looping. This root element, does it has children? So I know if it has children by this function, left children and right children. If you have a children, I will have here an array where I will say, okay, these are the elements that I need to visit. I will put here 1, and I will put here 2, because those are the children of this guy. Now what I will do is that after I will take the first element, I will add to my visited element. And when I'm adding element, I will check, do you have children? No, you don't have children. Okay. Now I will take this one. I will visit, do you have children? So when I will put 2, I will say, do you have children? Yes, you have 1 children. And I will put that children here to visit. So the idea is basically have a data structure where you are going to put element, and then have another data structure where you are going to put element that you need to visit. And now how do you detect cycle during this process? If you want to add an element which is already present, then it's definitely a cycle. For instance, let's say I'm here and this element 3 is actually pointing maybe to 2, or maybe pointing to any element that is already in the tree, right? Definitely is going to form a cycle. It's going to form a cycle because we have a tree which is actually a set of elements connected to each other. If you point to any of those elements in the tree, eventually, since all of the elements are actually connected to each other, that element is going to end up pointing to you again. So that's the idea here. So whenever you are going to add element, so that's how it's going to implement here. So whenever the element that you need to visit is not empty, that means you still have element to visit. You take the element, the current element you want to visit. You check if the element is already in your visited node, definitely is going to give you a cycle, so you return false. Otherwise, you actually add the element to the visited element, and then now you check if the left element is actually an element that needs to be visited. You add it to your list of to visit. If the right is element you need to visit, you add to the list of to visit. And then at the end you now need to check the completeness of the graph. So you can have something like this, and then you have a node here which is maybe 4 here. You are going to have something complete here, but at the end the total of elements that have been visited will be 4, whereas you have one left here which is per element. So you need to make sure that the graph formed by your visit process is actually a graph that contains all of the elements. If it doesn't contain all of the elements, that means we don't have a binary tree. That means we have separate components. So that's why here you are checking if the size of the visited element is actually equal to n. If it's equal to n, then cool, you return true. So this is my approach of solving this. I hope you do enjoy it. Feel free to leave me any comment. I'll be really happy to interact with you regarding this. Let us run and see what it gives. So you can see that it actually passed all the test cases. In terms of memory and performance, it's not the best for sure, but here you have a clear approach of how you can organize yourself to have this work and perfectly pass all the test cases. I'll be really happy to interact with you regarding this. If you have any input, don't hesitate to share. There is a link down to a Discord server if you're interested into any coding discussion related to data structure algorithm development. Don't hesitate to join. So see you tomorrow with new video. Ciao.